Okay, so today what we're going to do is that we're going to basically take the integral starting from negative infinity all the way to positive infinity of 1 over x squared plus 1. So in order to do this definite integral, first of all, it's improper because you got negative infinity and positive infinity. Those are the bounds. So because of that, we're going to have to split this up into two separate integrals. I'll just show you that right now. So this thing is going to be equal to, now we're starting at negative infinity, but the thing is that we're going to pick a number that's in between negative infinity and positive infinity. It's kind of a way to like chop up this integral into two integrals, okay? So for this one, I'll just pick 0, because 0 is a really easy number to work with. 0. And then you just write down the exact same thing. But then you gotta add the other integral that we're doing. So if we're going from negative infinity to infinity, well, obviously, if we're going from negative infinity to 0, well, we have to get to, infinity eventually. So we're going to start at 0 for this integral, and now we're going to positive infinity over here. And then, of course, you write down the exact same function, 1 over x squared plus 1. So now when you integrate this stuff, make sure that when you do this, you got to make sure that you basically use what I would call a dummy variable to kind of represent. You can't really plug in infinity into this thing, but what you can do is that you can have like a number, or not a number, but like a letter that kind of represents this thing, but make it so that the limit when it goes to negative infinity, and the same thing for positive infinity over here. So now we're going to rewrite those two integrals as, so I'm going to write as the limit, as I'll pick a, so when a goes to negative infinity of, and then we're replacing this guy, the negative infinity, with a. So 0 of 1 over x squared plus 1 dx plus, and now we're going to do the same thing, but obviously we're not going to use a again. We're going to replace this infinity with b, and we'll just take the limit when b goes to infinity. So now this is the limit when b goes to infinity of, so instead of writing positive infinity, we're writing b because we're going to let it approach infinity. And then of course you rewrite that function, x squared plus 1. So this is a pretty straightforward standard integral. It's just inverse tangent of x. So here we go. So we still got to write the limit. That's important. Negative infinity. Okay, that's going to be inverse tangent. And we're evaluating this guy from a to 0. And then we have this guy over here. We basically do the exact same thing. The limit when b goes to infinity of, we know that integral, we're basically going to do it again. And we're evaluating this guy from 0 to, whoops, I was supposed to write b here. Sorry. We're going to evaluate from 0 to b. So, of course, we plug it in, right? So now this is going to be the limit when a goes to negative infinity. So first we're going to plug in the inverse tangent of 0. Now we're going to subtract away the inverse tangent of a. So this is what we're taking the limit of when a goes to negative infinity. And then we're going to do the same thing here, plug in the b and the 0. So now it's the limit when b goes to infinity of, so it's the inverse tangent of b. And we're subtracting away the inverse tangent of 0. And we're taking the limit of this stuff when b goes to positive infinity. Now first of all, I want to point out a couple things. First of all, the inverse tangent of 0, well obviously that's just 0. And same thing for this guy. The reason why is because basically the inverse tangent function is basically asking you tangent of what gives you 0, right? And obviously we know that tangent of 0 gives you 0, so that means that the inverse tangent of 0 gives you 0. So with that being said, now we have this guy right here. We have to figure out what is inverse tangent of a when a goes to negative infinity. What would that be? Well, if you remember the inverse tangent of x graph, we know that the inverse tangent of 0 is 0, so we have our little point there. But then we have these horizontal asymptotes. We have two of them. This one is y equals pi over 2. And this one down here is y equals negative pi over 2. So basically how it works is basically that the tangent graph, but you just flip it over on its side. That's the inverse tangent graph. That's what it looks like. So when x is really large, when it's really positive, it's going to get really close to pi over 2. When x is really negative, then it's going to get really close to negative pi over 2, right? This is very similar to the original tangent of x graph, but this one is just flipped on its side. So now those vertical asymptotes that were on the tangent of x graph, now they're the horizontal asymptotes of this inverse tangent of x graph. So here, obviously when it gets really, really positive, y gets really close to pi over 2. When x gets really, really negative, y gets really close to negative pi over 2. So with that being said, we can figure out what this limit is when a goes to negative infinity. So if you just look at this graph, when x is really, really negative, it gets really close to negative pi over 2. So that's the answer for this limit. And of course, we already have a negative sign there, so be careful with that. So it's a negative, and there was already a negative sign there, so I'm just putting parentheses there, or brackets, whatever. So the limit as a goes to negative infinity of inverse tangent of a, it gets really close to negative pi over 2. And then we have this limit over here, which is inverse tangent of b when b goes to infinity. So when x gets really, really large, when it gets really positive, it gets really close to pi over 2. So that's what that limit is going to equal to. Inverse tangent of b when b goes to infinity is going to be pi over 2. So we're just going to add that. Alright, and not only that, but notice how it's negative, negative, so that's going to be positive. So now we're going to have, we end up having pi over 2 plus pi over 2. And obviously that's going to be 2 pi over 2. And obviously they cancel out, so now it's just left with pi. So this improper integral, first of all, it converges, and it converges to this answer over here, which is pi over 2. I'm sorry, it converges to pi. And we're done.